I'm here to talk about RMS velocity, root mean squared velocity. I'll explain what it is, and then I will briefly talk about what it's good for. Imagine we have a sealed container with an ideal gas inside. And imagine this ideal gas consists of just 3 molecules, each with identically the same mass, m. Let's suppose they have all different velocities. V1, V2, V3. Each molecule has a kinetic energy, 1/2 mv squared. The thermal energy of the gas is simply the total of all the kinetic energies of the molecules. If you average together all the kinetic energies and then multiply by the total number of molecules, you'll get the same thing. And of course, the temperature of the gas is directly proportional to the thermal energy. If the temperature is 0 kelvins, then there's 0 thermal energy, 0 kinetic energy, and all of the molecules have 0 velocity. Speaking of averages, presumably there is some kind of relationship between the average kinetic energy of the molecules and the average velocity of the molecules. The bigger the velocity, the bigger the kinetic energy, and vice versa. What do you suppose this relationship is? If you've got a gas and one of the molecules of the gas happens to have a kinetic energy exactly equal to the average kinetic energy of all those molecules, will that molecule also have a velocity that is exactly equal to the average velocity of all those molecules? The answer is no. So what is going on? Let's find out. Let's remember the definition of average for a moment. If we've got 3 molecules and you want to find the average velocity of those 3 molecules, you simply add them up and divide by 3. Now, it's not quite as simple as I made it look, because in 3-dimensional space, your velocities will each have 3 components, but you can add up the x, the y, and the z components separately, and each one of them will follow this same pattern. So here we have an empty jar. There are a bunch of air molecules inside this jar. What is the average velocity of those molecules? Answer: 0. It doesn't matter what the temperature is. Forget about this stuff. It's 0 regardless of the temperature. Because you're going to have molecules going right, going left, going up, going down, etc. If molecules going to the right have a positive velocity, then the molecules going to the left will have to have a negative velocity, and so on and so forth with the other dimensions. So if you've got trillions and trillions of molecules in there, some will have positive velocities, some will have negative velocities, and they will all add up to be a big 0, and the average velocity in all 3 dimensions will be 0. So the truth is, average velocity is useless information. It does not help us with any of this. So what can we do instead? How about this? Average speed. We can find the speeds of the molecules by taking the absolute values of the velocities. Speed is never negative, so you won't have negatives canceling out positives. The sum will not be 0, it will be a positive number, and it will be a meaningful quantity. The greater the individual speeds, the greater the average speed, and certainly the greater the speed, the greater the kinetic energy, and so on. But there's a problem with average speed, because doing algebra with absolute values is a headache. It can be done, but you don't want to do it. I don't want to do it. And the good news is we don't have to do it because there is a better way. So I reverted this back to the way it was before, but I've changed the notation slightly. Instead of average, I'm calling it mean, which means the same thing. And V sub m means mean velocity. Well, what about root mean squared velocity? Well, let's start with mean squared velocity. Mean squared velocity is the mean of the squares of the velocity. And you get it by squaring the velocity first, then taking the mean. This is another way to finesse the problem of negative velocities. A squared velocity is never negative, So this whole thing will add up to some positive value, just like we saw with the average speed. But the advantage is that it's much easier to do algebra with squared values than it is with absolute values. Very well then, what is root mean squared velocity? That's where you take the square root of all of this. It's the root of the mean of the squares. There's the square root of the mean of the squares. And this is what it looks like when you have three molecules with the three velocities. What if you have more molecules than that? Well, it looks like this. If you have n molecules, you just add them up, v1, 2, 3, 4, 5, 6, up to vn, and then divide by n. Another way to write this, using sigma notation, that's just the same thing as that. The good news is, we don't need to bother with this stuff much of the time. So we've defined root mean squared velocity. Now let's see what it's actually good for. Allow me to do a little algebra. Let's start by squaring both sides of this equation. There you go. Square the left side, cancel the radical on the right side. Next step, let's multiply both sides of the equation by 1/2 m, where m, of course, is the mass of those molecules. And on the right side, I'm going to distribute the 1/2 m to all three terms there. Now, the meaning of this is not immediately clear, but I think these are pretty obvious. There's your mass, and there's velocity 1, there's velocity 2, there's velocity 3. These are the kinetic energies of these three molecules. And I don't think it comes as a shock to anyone when I tell you if we add up the three kinetic energies and divide by 3, you're getting the average kinetic energy. So you can see when you have a collection of molecules, if one of those molecules happens to have a kinetic energy exactly equal to the average of all the molecules, it will have a velocity equal to the RMS velocity. And this RMS velocity is certainly not equal to the average velocity or the average speed. If we had tried to do a similar sort of calculation using the average speed formula, it would have been a lot harder, and we would have got something here that would have been a lot more complicated. In conclusion, RMS velocity is approximately equal to average speed, but we prefer to use RMS velocity in many situations because it makes the math easier. Thank you very much for watching. Please like and subscribe. Here are a couple of more videos that I've made on related topics. Also, if you're interested in being tutored online by me personally, I am available, and there's some information about that down below.